Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. In the world of wired networking, twisted pair cabling plays a foundational role in establishing reliable and high-speed local area connections. These cables physically link computers, printers, phones, and network infrastructure. But performance depends heavily on the type of cable selected. To provide guidance and ensure compatibility between devices, industry organizations have defined a series of cabling standards. These standards specify the capabilities of each cable category and help network professionals make informed decisions about installation, maintenance, and future upgrades. The Network Plus exam emphasizes these standards because they relate directly to network speed, port capabilities, and installation practices. You will often encounter questions that require matching cable categories to Ethernet speeds or identifying the right type of cabling for a specific scenario. Understanding how each category performs and where it fits into modern networking environments gives you a strong advantage both for the exam and for practical fieldwork. These distinctions are essential in physical layer troubleshooting and planning. Category 5, often referred to simply as Cat 5, was once the standard for Ethernet installations. It supports speeds up to 100 megabits per second and is rated for frequencies up to 100 megahertz. Cat 5 cabling was widely used in homes and offices, but it has since been declared obsolete and is no longer certified for new installations. In environments where Cat 5 still exists, it may limit the network's upgrade potential due to its speed and bandwidth constraints. Category 5E, or Cat 5 Enhanced, introduced improvements in crosstalk reduction and signal integrity. While it looks physically similar to Cat 5, it was engineered with tighter twist tolerances and improved performance for higher data rates. Cat 5E supports speeds up to 1 gigabit per second and remains common in many modern installations. It offers a good balance between cost and capability, especially in networks that do not yet require multi-gigabit throughput. Category 6 takes things further by increasing the cable's frequency rating to 250 MHz and incorporating better internal separators to reduce interference between wire pairs. It supports 1 gigabit per second over the full 100-meter internet limit and can achieve 10 gigabit speeds over shorter runs, typically up to 55 meters. Cat 6 cables are often used in new commercial installations where long-term performance and headroom are desired. Category 6A, or Augmented Cat 6, improves upon Cat 6 by supporting 10 Gigabit Ethernet over the full 100-meter range. It features thicker insulation, more consistent twist rates, and overall better shielding to prevent alien crosstalk from adjacent cables. While Cat 6A is heavier and less flexible than Cat 6, it provides the performance needed for high-speed applications in modern enterprise networks and data centers. Many structured cabling systems now use Cat 6A to future-proof installations. Category 7 and Category 7A push cable performance even further, though they are less common in standard enterprise environments. These cables support frequencies up to 600 or 1000 MHz and include individually shielded pairs as well as overall shielding. They often use connectors such as GG45 or Terra, which are not backward compatible with standard RG45 ports. As a result, these cables are typically found in specialized high-frequency environments or where shielding requirements are especially strict. Category 8 represents the newest advancement in twisted pair copper cabling. It is designed specifically for short-range, high-speed data center links. Cat 8 supports transmission speeds of 25 or 40 gigabits per second, but is limited to a maximum length of 30 meters. It uses shielding and tight electrical specifications to reduce interference and is intended for environments where high throughput and low latency are crucial. Due to its short range and cost, it is generally not used for general office cabling. All higher cable categories are backward compatible with the lower ones. This means a Cat 6A cable can be plugged into a device rated for Cat 5E, and it will operate at the speed of the lower-rated port. Compatibility includes connector types as well, with most twisted pair cables using the RJ45 connector, which is standard across Ethernet devices. However, the quality of the cable still matters. Using a high-category cable with poor connectors or sloppy installation can negate the benefits of the upgraded rating. In each category, cables may come in different shielding configurations. Unshielded twisted pair, or UTP, is the most common and is suitable for environments with minimal electromagnetic interference. Shielded twisted pair, or STP, includes a protective layer to block interference and is used in electrically noisy environments. Foiled twisted pair, or STP, uses foil shielding around individual pairs or the entire cable. The installation environment usually determines whether shielding is necessary. Shielded cables require proper grounding to work correctly. After installation, copper cabling should be tested and certified using professional cable testers. Certification ensures the cable meets its rated performance category and is free of faults like miswiring, split pairs, or high resistance. Testers can verify signal quality, measure attenuation, and check for crosstalk or impedance issues. This is especially important in environments with high-speed applications, where even small imperfections in cabling can lead to significant network problems. Cabling standards give network professionals a clear framework for designing and building reliable infrastructure. Choosing the right cable category is about more than speed. It also affects installation difficulty, cost, cable size, and shielding requirements. As data rates increase and environments grow more complex, understanding these categories becomes more important than ever. Whether in small office networks or large data centers, the right cabling decision can determine the long-term success and scalability of the entire system. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Each cable category is defined not only by supported speed but also by frequency rating. Frequency, measured in megahertz, determines how much data a cable can carry at once. For instance, Cat5e is rated for 100 MHz, Cat6 is rated for 250 MHz, and Cat6a is rated for 500 MHz. Higher frequency ratings allow cables to transmit faster signals, which in turn supports higher data rates. These frequency capacities are part of what enables 10 Gigabit Ethernet on Cat6a and above, as faster transmissions require wider bandwidth. Beyond frequency and shielding, cable jackets and insulation types are essential factors in determining where and how cables can be safely installed. Some environments, such as ceilings used for air circulation, require plenum-rated jackets that resist flame and emit less toxic smoke. These cables are marked CMP for communications plenum. Cables running vertically between floors must be rated for riser applications and are labeled CMR for general non-airflow spaces. PVC jacketed cables are usually sufficient. Choosing the correct jacket type helps maintain compliance with local fire codes and ensures the safety of occupants. When considering new installations, future-proofing is one of the most important goals. While Cat5e is still capable of delivering gigabit speeds, it is no longer the best long-term choice in many environments. Choosing Cat6 or Cat6a may cost slightly more initially, but it enables faster speeds and longer relevance as bandwidth demands grow. For high-performance applications or networks expected to last 10 or more years without replacement, higher categories provide headroom and flexibility. Planning for growth avoids costly rip-and-replace projects later on. Distance limitations also vary depending on the cable category and intended speed. Most twisted pair Ethernet standards limit total cable length to 100 meters. This includes the horizontal run plus patch cables at each end. However, Cat8 is an exception. It supports 25 or 40 gigabit Ethernet, but only over a maximum of 30 meters. This short range makes Cat8 ideal for use inside data centers, where equipment is closely clustered. For longer runs beyond the limits of copper, fiber optic cabling or the use of Ethernet repeaters becomes necessary. Cable categories and their standards are not random. They are defined by global standards organizations that set uniform benchmarks for performance and interoperability. In the United States, the Telecommunications Industry Association, TIA, and the Electronic Industries Alliance, EIA, develop structured cabling standards under the ANSI/TIA 568 series. Globally, The International Organization for Standardization, ISO, and the International Electrotechnical Commission, IIC, help ensure that cables meet consistent requirements across manufacturers and countries. These standards allow for confidence in cable performance no matter where or by whom they are produced. Identifying cable type during installation or inspection is usually straightforward if you know what to look for. Most Ethernet cables have markings printed along the jacket. These markings include the cable category, such as Cat5e or Cat6a, and may also indicate shielding type, jacket rating, and manufacturing information. UTP cables are often marked as such, while shielded cables may carry labels like STP, FTP, or S/STP, depending on the shielding design. Technicians should always check these markings before installing to verify they are using the correct cable for the job. In high-speed environments such as data centers, choosing the right cabling is critical. These environments often operate at 10 gigabit speeds or higher, and any interference or signal degradation can have serious consequences. For this reason, Cat6a, Cat7, or even Cat8 cabling may be used. Shielding becomes increasingly important as data rates rise, since higher frequencies are more susceptible to crosstalk and electromagnetic interference. Proper grounding, tight twist rates, and precision terminations all play a role in maintaining performance and reducing error rates. On the Network Plus exam, cable categories frequently appear in a variety of question formats. You may be asked to match a category to its supported speed, select the right cable type based on a wiring diagram, or identify the implications of exceeding maximum cable lengths. Questions might also involve interpreting printed cable markings, identifying the type of shielding required in certain environments, or evaluating which category is most appropriate for a new installation. Solid command of these distinctions is essential to passing the exam. Understanding twisted pair cabling standards is not just about memorizing numbers, it is about knowing how each category fits into network design, how it supports current and future applications, and how to install it properly to ensure maximum performance. These standards form the backbone of modern Ethernet networks, and they serve as a roadmap for how copper cabling continues to evolve. Whether you are installing cables, planning upgrades, or preparing for the certification exam, this knowledge will help you make better decisions and support more reliable wired connections. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.